What if I told you that a thin film of slime, barely visible on the hulls of ships, was quietly driving up global emissions, polluting our oceans, and spreading invasive species worldwide? This hidden problem is called biofouling, and it costs our planet dearly. Today, I want to share how Hullbot, an Australian startup, is using AI-powered underwater robots to transform that hidden challenge into a sustainability win, while advancing key UN SDGs and embodying responsible leadership. So let's dive in. Biofouling happens when slime, algae, and barnacles cling to a ship's hull. It may seem minor, but the impacts are enormous. Biofouling reduces ship speeds by up to 86%, forcing more fuel burn. Even thin slime can increase fuel consumption by over 25%. Overall, biofouling leads to 1% of total global emissions. Also, it is the single biggest pathway for invasive marine species to spread. The traditional fix, anti-fouling paints alone, have questionable efficacy and release toxins and microplastics. This is a hidden problem that accelerates climate change, damages marine ecology, and pollutes our oceans. This is where Hullbot steps in. Its underwater robots use computer vision and AI to autonomously map, navigate, and groom ship hulls. Unlike traditional reactive cleaning, Hullbot is proactive, removing fouling in early thin slime stages. This process is chemical-free, carried out in the water to minimize disruptions, and operates day or night. In one trial, the NRMA Manly Fast Ferry fleet saved 16% on fuel by adopting Hullbot's proactive grooming. Cleaner hulls mean lower costs, safer seas, and significantly fewer emissions. Hullbot's mission to decarbonize maritime transport is directly aligned with SDG 13, climate action. The logic is simple but powerful. Less drag means less fuel, and less fuel means fewer emissions. And with shipping accounting for 3% of global emissions, every bit of efficiency matters. Hullbot's AI-based approach can deliver reductions of 13 to 26% of fuel use, providing strong business and environmental incentives. And Hullbot makes vessels efficient today without waiting for future fuels or new ship design. Hullbot also advances SDG 14, life below water. By keeping hulls clean without biocidal coatings, it mitigates the release of harmful chemicals and microplastics into the ocean. Hullbot also disrupts the spread of invasive species, protecting fragile marine ecosystems. In short, Hullbot turns routine ship maintenance into a holistic tool for improving ocean health. However, good technology alone isn't enough. Hullbot's founders demonstrate responsible leadership by engaging across the system. They partner AI robotics with ferry operators, environmental groups, and regulators to align commercial operations with planetary health. Working with diverse stakeholders reflects a core practice of responsible leadership, building shared value through collaboration. Hullbot operates on a principle of and thinking. Too often, business leaders treat environmental sustainability and financial performance as either-or metrics. Hullbot's model shows it can be both. Cleaner hulls deliver cost savings and reduce emissions at the same time. By embedding strong values into their business strategy, Hullbot demonstrates that leadership grounded in purpose can innovate in ways that benefit both people and the planet. Naturally, innovation comes with trade-offs. Automating hull cleaning with AI replaces traditional divers, an issue relevant to SDG 8, decent work. But it also removes people from dangerous underwater tasks, and it creates new opportunities in AI operations, robotics maintenance, and marine data services. Another consideration is extra emissions caused as Hullbot transports robots across the planet. Regular global service requires extensive travel, and the impact can add up. However, the extra emissions are more than offset by fuel savings unlocked, and as air travel transitions to renewable energy, this balance becomes more positive. Ultimately, responsible leadership means recognizing trade-offs and designing systems to mitigate them. My personal takeaway from this case study is the power of prevention and partnership. Hullbot doesn't wait for fouling to become a crisis, it prevents it early with positive ripple effects across climate and biodiversity. For me, this highlights the importance of self-reflection, designing initiatives with SDG outcomes in mind, and co-creating solutions with stakeholders while balancing ROI with real-world impact. Prevention and partnership will guide my approach to leadership. Hullbot is one story in a bigger movement of AI for good, where technology is deliberately steered to tackle humanity's toughest challenges. The key is responsible leadership. That is, aligning innovation with ethics, engaging stakeholders, and designing for long-term impact. So the next time you see a ship glide across the harbour, remember that responsible leadership and technology are tackling hidden problems together to unlock a healthier planet for all. Thank you.